Helicopters are amazing aerial vehicles capable of quickly getting to places most other forms of transportation would find difficult or impossible. But this begs the question, what is a helicopter exactly, and how do they work? Hi, I'm Fritz, and this is Fritz Does STEM. Today I'm explaining the mechanics of helicopter flight. But what is a helicopter exactly? According to the Oxford English Dictionary, a helicopter is a type of aircraft which derives both lift and propulsion from one or more sets of horizontally revolving overhead rotors. While there are many different types of helicopters that can use multiple sets of rotors, for the purposes of the video, we will be discussing the classic style with only one rotor. Helicopters are capable of moving in all 6 degrees of freedom. To accomplish lateral movement, helicopters will pitch or roll their main rotor in the direction of desired movement. To demonstrate this, I've hopped on the game Stoneworks Build and Rescue, where I'm using a helicopter created by the user Mr.NJersy, which I have linked in the description, along with all of my other sources and software used in the creation of this video. As you can see, when I pitch the helicopter forward, or down, the helicopter will move forward. When I pitch the helicopter up, or backwards, the helicopter will move backwards. Subsequently, if I roll to the right, the helicopter will start moving to the right. And when I roll to the left, the helicopter will move to the left. But how do you control a helicopter? If you have ever wondered how a helicopter controlled how fast it goes up and down, you may have thought it did this by making the rotor spin faster or slower. It makes sense. In a normal plane, when you increase the throttle, it goes faster. However, in a helicopter, the RPM, aka rotations per minute, of the rotor remains about the same the entire time. To explain this, I'm using the software Fusion 360, where I've modeled a helicopter rotor. If you look at the blades, they almost look like mini, long wings. That's because that's precisely what they are. By spinning very fast, they generate lift that will pull up on the helicopter. You can change how much lift they produce by changing their angle of attack. When the angle attack is greater, like it is here, they will produce more lift than if the angle attack is less, like it is right here. By making the angle of attack higher to generate more lift, you will make the helicopter go up. But how do you control the angles of the blades? The helicopters use something called the swash plate to control the angle of attack of the rotor blades. The swash plate is this donut-shaped thing right here below the rotor blades. The swash plate consists of 2 sections, one section that doesn't rotate and one that does. The bottom non-rotating section of the swash plate is connected to your flight controls in the cockpit, and the top rotating section of the swash plate is connected by these control linkages to the rotor blades. By pushing up on the swash plate, you will be pushing up on the rotor blades here, which will cause them to rotate and make the angle of attack greater. However, the swash plate is not just used to control the collective. It is also used to control the pitch and roll of the helicopter. By pitching and rolling the swash plate, you can make the helicopter pitch and roll. When I pitch the swash plate like I did here forward, it will make the helicopter want to pitch forward. When I pitch the swash plate forward, you'll notice that one end of it is higher and the other end is lower. You also notice on the end that is higher has a higher angle of attack on this side, and the blade has a lower angle of attack on this side. You also notice that the angle of attack on the blades will change as they go around the swash plate. As you can see right here in the middle, they're about the same. To better understand why this makes the helicopter pitch and roll, hold an object with both of your hands. If you push up on the object with one of your hands and push down with the other, you'll notice that it'll make the object rotate. When the rotor blades pass over one side of this wash plate, they're producing more thrust, and when they pass over the other side, they're producing less thrust. This means that this side has more thrust than this side, and it's going to make the helicopter rotate. Using this, helicopters are able to pitch in any direction and control how much they go up and down. For this final section, I have hopped back onto Stormworks. Because of Newton's third law of motion, every action has an equal and opposite reaction. When you spin the rotor blades very fast, the rotor blades will want to make the helicopter spin in the opposite direction. To prevent this and keep your helicopter from constantly spinning, we have something called the anti-torque. The anti-torque is like a small propeller on the tail of the helicopter that produces thrust to counteract the spinning. To show you what happens when you don't have this, or it breaks on your helicopter, I have removed the anti-torque from the helicopter I used earlier. As you can see, when I lift off the ground, the helicopter starts spinning uncontrollably. I have no way to prevent this spinning, and it'll keep going until I land, and the friction on the ground keeps the helicopter from spinning. Now that I'm in a helicopter that has the anti-torque, you can see that the anti-torque also serves as the helicopter's main method for turning left and right. Thank you for watching. Hopefully you've learned something from this video. Remember to like and subscribe for more STEM-related videos. I have some ideas and things planned for this summer, and I'm excited to finally get this channel going. This has been Fritz from Fritz Does STEM. Stay curious.